Hello. Hi, everyone. Welcome to day 2 of Hackfest. I'm so happy to be here with everyone, and hello to the virtual crowd as well. My name is Lena. You can also call me Inverse, or if you're super formal, you can call me Inverse Cos. And today I'm going to be talking to you guys about hacking the cloud like an APT. Now, my background is in blue teaming and in IR, and I know I'm at a red teaming conference, so just take it easy on me. I'm trying my best. So before we start talking about the cloud and I delve into what I want to cover, I want to set the scene a little bit and talk about why we're even having this discussion about the cloud. And I really like these statistics that I pulled from Checkpoint. And in the stats, they said there's been a 48% increase in the types of attacks that infiltrate the cloud since 2022. And I would say from my experience working in IR, that has been exactly the case. I would say from like 2021 through to 2023, almost like, I think in like 2022, almost 95% of the casework that I touched was in the cloud. Not fully in the cloud, but like part on-prem, part in the cloud. And that's been like a growing theme in the types of cases I've worked. And what's really interesting about the stats is that they've also mentioned that 56% of organizations struggle with some kind of cloud skills and not knowing what to do. And this, I think, is a pretty big stat, and it measures things like not knowing how to remediate threats, not knowing how cloud attacks work, and not knowing how to detect these attacks. And if you think about the stat, it's kind of scary because 98% of global organizations utilize some kind of cloud service, whether it's Entra, and also I'm a stickler for Azure AD. So if you catch me saying Azure, I mean Entra, even though Entra is giving like entrails. So it's either Entra, GCP, AWS. And so what is the problem? And I think it comes down to quite a few things. I think the first thing is there is a high knowledge barrier. And this isn't the case of knowing what attacks are, but a high knowledge barrier in terms of blue teams being able to detect some of these attacks. And I hope through this presentation, I'll be able to elucidate why that is the case and why detection around the cloud is actually kind of difficult when you're doing an IR or performing an investigation. Even though there are logs, I'm going to give you guys examples. The second thing is a lot of the remediations that blue teams apply when it comes to IR focus a lot solely on-prem. Even when you think about commodity-based threat groups like ransomware threat groups that deploy ransomware throughout the infrastructure, a lot of the remediations blue teams apply focus on-prem. And this is kind of problematic because there's been a growing trend where commodity threat groups are also moving their ops into the cloud. For example, Black Hat ransomware crew are now encrypting storage accounts inside Entra as well. And I've seen instances where in casework, where the persistence mechanism inside the cloud hasn't been caught, and then that later on leads to a re-entry by the threat group again. And then the third thing are still some misconceptions about the cloud. Does 2FA protect me? How strong is 2FA? Will that stop threat actors from intruding? Confusion around 2FA. And then lastly, a lot of organizations are hybrid, so on-prem and also in the cloud, or they're fully in the cloud. And why is this a problem? Because depending on the type of hybrid setup you have in your environment, that opens you to a series of different lateral movement techniques that allow you to move from on-prem to the cloud. And this type of attack is what a lot of the APT threat groups are focusing on when they, break through your egress, land in your on-prem environment, and perform the lateral movement. And so it's not a question of, are these kind of attacks happening? They are happening. A lot of it is remaining undetected. And this occurs all the time in IR, where you touch a case, but the case has already been worked by other consultancies. And it's almost like they're passing the case from consultancy to consultancy. And the reason is persistence mechanisms not being found, things not being detected, confusion around attacks. It occurs all the time. And here are just some threat groups that have historically performed cloud attacks. Now, it's not a threat intel talk. I'm not going to bore you by giving you the history of each one of these threat groups, but just some key examples. My favorites, APT 28 and APT 29, both Russian-based threat groups. APT 29, very notorious for the SolarWinds breach, during which they performed a golden SAML attack, which facilitated them moving from on-prem to the cloud, and we're going to cover that a little bit. They've also done things like performing Azure AD backdoors. Back then it was called Azure AD, Entra ID backdoors, and APT 28 abusing things like OAuth 2 protocols and abusing service principal accounts, which gives them, single factor access into the cloud directly. No need to steal tokens. Now, in terms of APT 41, this is a Chinese threat group, and they are a threat group very near and dear to my heart. And yeah, they're Chinese. No, I'm not related. The reason is because back in 2021, 2022, I worked 5 cases with this threat group back to back. And during this period, it was like a part of a big political campaign that they were targeting at the time. And during this period, each one of the intrusions had a cloud component to it. And all of it was doing things like abusing legacy authentication protocols to move into the cloud. And then all the exfiltration that occurred and the data access was all in the cloud. Because if you think about it from the perspective of espionage from an APT group, they're interested in projects that a company or, like secret projects or parts of work deals that are happening in a company. They're not really, maybe they're interested in patents and IP, but they want to know what's being developed and what's occurring. And so that exists in conversations, documents that you share with each other on Teams, SharePoint, things being shared on SharePoint. Makes sense. And so, once again, I kind of have to touch a little bit about this threat group, Storm 0558. They are a Chinese threat group. There's like advisories about this from Microsoft and also from WIS. And the TLDR for this, I'm not going to go through the history of what happened here, but the TLDR was that an engineer's account was hijacked, and this engineer's account had access to a debugging environment. And inside the debugging environment, there was present a crash dump. And due to a race condition, there was a signing key present. The implication of the threat actors getting this crash dump and getting the signing key was that for a 2-year period, they were able to impersonate and access resources inside the cloud. And these resources were not just Outlook and SharePoint. It could have been any resource. And this is kind of the nature of the type of attacks that threat actors are interested in. They're primarily interested in impersonation type of attacks, and we're going to talk about that today. And yes, it's a keynote. And no, I'm not going to be going into super technical detail around what's happening, but I want you guys to walk away with an appreciation of the types of attacks that happen in the cloud, how they work, and really just how exciting the space is for a red teamer and how much of a sad life it is for a blue teamer. So I want to cover a few things. So the first thing is I want to talk a little bit about an MFA bypass example, and then I want to move and talk a little bit about on-prem to cloud. And the reason I want to talk about on-prem to cloud lateral movement are these techniques are used in the wild, and they are the focus for a lot of these groups. And there is little to no, I don't think there's that much conversation going on around how these attacks work. So I hope that I can kind of elucidate this a little bit. And then lastly, just a wrap around where it's headed, what's going on, and what you can do. All right, so tokens, token abuse. I'm sure if you're on Twitter, X, I think Zeta, X. I actually don't know the name of the app. If you're on that app, you'll see like blogs all the time about token being stolen, token happening, token, pass the token, tokens everywhere. So let's just go back a step. What is a token? Think of it like a string that grants you access to a specific resource or several resources. And the reason why a threat actor would want to steal a token is if you think about the authentication flow, you're putting in your username and password and your MFA prompt, if any, and yes, some companies still don't have MFA. The token is then generated, and if you steal that, you bypass MFA. And in the world of Microsoft, the word token is almost like an umbrella term. There are so many different types of tokens you can steal. It's not just one type of token. There are things called access tokens that grant you access to a specific resource, and they live for 60 to 90 minutes. Then you can steal something called a refresh token, which refreshes an access token if your access token expires. Then there's things called primary refresh tokens, which exist if you've got single sign-on enabled in your environment. And then there's also things like SAML tokens. Anyway, the list goes on. You get the gist. There's so many different types of tokens in the Microsoft environment and so many different types of things you can steal and play with. And so I want to talk a little bit about this write-up from Mr. Docs. And if you were here yesterday, you would have seen Ruben's amazing talk as well about this technique. So I recommend you guys go check out his talk from yesterday as he goes into a lot more detail and approaches this a different way. So stealing apps from Office. So if you've ever opened up your PC and looked at PowerPoint, Excel, Word, and ever wondered, like, how does it know you're logged into lena@company.com? How can you save a file and that file is automatically saved into your SharePoint drive? And the reason behind this is there are a series of tokens embedded inside the process. And if you think about it, what you can do then as a threat actor is once you've pivoted onto the environment, you can create a dump of a Microsoft process like Excel, PowerPoint. I'm trying to think of like an Office app, and I can just think of Excel and PowerPoint. What else is there? Teams? Is Teams an Office app? I actually don't think Teams is an Office app. Word, yeah, Word if you're writing reports, which we all love to write reports. So if you create a dump of that process, and in this instance, I'm using Process Explorer just because it's like sexy on a slide, it's colorful, but you can do it any way you want. You can use run DLL32, look for a lol bin with a mini dump function, whatever method you want to use. I'm just going to target Excel. And if I create a dump of Excel, I can look for tokens inside the process dump. And you're looking for something called JWT, which stands for a JSON Web Token. And it typically starts with the string EYJ, sometimes EYJ0, something like that generally. And I'm just using strings here, but if you're like a real masochist, go ahead, use WinDebug, you know, whatever method you want to use. Like if it makes you feel sexy when you're on the CLI, go ahead. So whatever you want to do, go ahead. You can look for a bunch of JWTs, and there's heaps of them. Like you'll be able to see several, and they will point to resources like, I don't know, like Outlook. I love Outlook. For some reason, every time I talk about Azure resources, my brain just goes Outlook, and then I mind blank and can't think of any other resource, even though there's like 200. So like, I don't know, Outlook, SharePoint, OneDrive, you know, things like that. You get the gist. We're all Microsoft users for here, I think. I'm not sure. So you'll look for the JWT. And then the next thing is you want to find a JWT or an access token that matches what it is that you want to access. So in this instance, haha, I'm a hacker. I want to go and read all of Lena's emails. So in this instance, I would want to look for a JWT that pertains to Outlook that allows me to read my emails. And the way that you can see what the token gives you access to or what resource it gives you access to is you can use like a website like jwt.io. I like it because it makes it pretty, but if you're hardcore and just like to see it like clobbered together, you know, that's your style. So this, you can see I've got a token that pertains to Outlook, Office 365. Okay, great. But what permissions does it give me? And this token will also give you information around what APIs or what's the functionality or what can I do with this specific token. And I think, to be honest with you, I don't really think you need to go read like documentation on what this is. If you could speak English, it looks pretty self-explanatory. Read, write, mail, access, user. I think it's pretty self-explanatory. But if you're confused about these APIs, you can go look them up. There's documentation. Just go to google.com and type it in. So you can look for the writes. And in this instance, my action on objective is I want to go and I want to read all of Lena's emails. And so in order to do that, it's pretty simple. You can just interact with Graph API. And in this instance, I'm just doing this using curl. I'm just sending a post request to Graph, pasting in the token, and voila, I've got all of Lena's emails. You can see I've got emails from Lena, Lena's account from December, and you know, privacy reasons, blacked it out. Don't really want you guys reading my emails, but yeah, that's kind of the gist. But you can steal tokens for anything. You can steal them for SharePoint. And in the instance of APT 41, that's what they were doing when they were iterating through thousands and thousands of SharePoint sites, looking for specific things that they wanted to, I guess, read or gather intel on. It's really common and happens all the time. This is not a new attack. And what's really interesting about the premise of this attack and why I wanted to cover this attack is I think it's important for red teamers to understand from the perspective of blue teamers how they detect these attacks and gaps that allow you an opportunity to abuse it. And one of the things is when a blue team gets an alert like, oh, hectic, there's a dump on my system. Great. Oh, is it LSAS? No. Weird. It's Excel. What does that mean? I don't know. Let's look for context around it. Okay, I don't see much context. Let's close it. Not really sure what this means. The whole point is that when blue teams perform detection and they perform triage, it's a combination of contextual evidence around what the alert is, and also an understanding of the types of attacks that happen and what they are precursors to. And so if you're dealing with a SOC analyst or, your SOC analyst isn't fully or hyper aware of the types of attacks that occur, they may not have any ability to understand that seeing a dump of Excel, what that actually can lead to and how much of a high sev alert this is. And this is where things escape detection. And this is where you get incidents where you read the incident report and you go, damn, that's so obvious. But from the perspective of a blue teamer, it's like tiny little pieces of information that slip the awareness of the blue teamer's ability to, they're just not aware of what they're looking at. And the context of everything gets lost. And obviously also, when you're reading an incident report, everything is really obvious in hindsight, but when you're in the stress of things, some things you just interpret a bit strange. So let's talk a little bit about lateral movement from on-prem to the cloud. And I'm not going to bore you too much by giving you the history. I talk about AD. I know I talk about AD and people their eyes frost over and they just fall asleep in front of me. So I'm not going to go into too much detail about this, but it's really important to know this. And the reason for this is depending on what hybrid setup your environment has, it makes you susceptible to a different type of attack. For example, there's 3 types of hybrid models that can occur. You can have something called intra-password hash sync. And this is where your hashes on-prem are synced to the cloud through an agent. Then you can have pass-through authentication, which is where I open up a browser, I go Lena at Hotmail, not Hotmail, Lena, whatever my username is, my password, and then my creds are sent actually in plain text to an agent that sits on-prem, and where that agent sits depends on where the sysadmin installed the agent, to an agent on-prem. And the on-prem agent goes, oh, sick, correct credentials, let Lena access whatever she wants to access, Outlook. And then the third one is Federation, which is where I'm sure you guys have done pen tests and stuff where you guys have, tried to spray, type in usernames and passwords, and it will say something like redirecting you to your organization's homepage or redirecting you to your homepage. Yeah, I'm seeing some nods. Okay, yeah, so when you see that, it means that the environment is using Federation. Okay, why do you care? Why am I talking about this? Why does this matter? Because depending on the type of hybrid model, it makes you vulnerable to a specific attack. For example, Federation, you're vulnerable to golden SAML. Pass-through authentication, you can abuse with skeleton keys on the agent itself. And the reason I say this is I have legitimately seen blue teams create entire hunt hypotheses where they go, oh my God, SolarWinds attack, let me just hunt for that. And they start hunting for a golden SAML attack in an environment that uses pass-through authentication. It's the premise of the understanding that I think it really shows. And that's why I really like the checkpoint stats, because there really is a skill gap knowledge or a fundamental knowledge, a baseline knowledge that leads into decision-making errors that lead to things escaping detection, not knowing how to hunt things, incorrectly building hypotheses, and red teamers get away with things, essentially. And so let's talk a little bit about pass-through authentication. And I want to give you guys an example of something that you can do to abuse pass-through authentication to facilitate lateral movement. And the technique that we're going to talk about is a skeleton key attack. I'm sure you guys have heard about skeleton key attacks, probably in the premise of performing it on LSAS or something like that. But if we take a step back, and for the people listening who don't know what a skeleton key attack is, it's literally a key that I think they get rid of the knobs. I'm not a physical security person. They get rid of the knob things, and then it opens several doors. That's kind of literal example of it. But in this instance, what we're going to do with it is we are going to backdoor the pass-through authentication agent, and it's always the same executable, and it's always running. And we're going to use that to literally man in the middle and gather credentials that we need in order to access the cloud. And so I pulled this technique from an awesome write-up from Adam Chester, and I've got his link there as well. And essentially, the premise of the attack is it assumes that you've already breached the environment on-prem. So you've breached the environment on-prem, and you need to look for the host where pass-through authentication is installed. And you want to inject your malicious code, inject your DLL into this executable. And it's generally called something like, and I don't remember this from the top of my head, Azure AD, and I'm reading it off a slide, by the way. Azure AD Connection Authentication Agent Service is generally called something like that. And what you then want to do is you want to patch the logon user W API function, and you want to store all the passwords. So every single time Lena is typing in her creds, trying to access whatever legitimate site I want to access, that is being patched, and the threat actors are monitoring and sniffing out all the plain text creds that you're passing through. And this is kind of what it looks like. Azure AD Connect WildStar agent is constantly running. It invokes a call to log on user W. It triggers my malicious hook. And my hook is copying all the credentials somewhere. Maybe I'm forwarding it on. Maybe I have decided to accept credentials for any password with the word fish. So the attacker can log in to any user account with the password fish. Whatever it is you want to do, you do that. And then Azure AD Connect just runs as per usual. And if you're not into writing your own framework or writing your own DLL, you don't want to do this, you can always use like a pre-built tool. And a tool that does this is AAD Internals. This is an awesome tool. The implementation of this tool is a little bit different. NetStory's implementation creates a series of things on disk, which is really noisy from a blue team's perspective. Anytime something touches disk, it's so noisy. Even if EDR is bypassed, it's like not that difficult to detect. In terms of Adam's implementation, he just utilizes named pipes. And so you might then have the question of, why would I use a framework like AAD Internals? You know, I want to be super sexy and stealthy. I don't want to install any tools onto a disk. What kind of threat actor would use this? And you'd be surprised. Several APT groups have leveraged NetStory's tools to perform their operations. And I think this kind of beckons a larger question around sophistication, concepts around APT groups, what you think about sophistication. And the answer is it's like a big tree. APT is like an all-encompassing word for several threat groups. And the sophistication levels vary because sometimes when you're dealing with an APT group, you're not actually dealing, even though it's coming from China or whatever country it's coming from, you're actually dealing with a specific unit comprised of several contractor organizations. And these contractor organizations may not specifically work for that nation state. They might contract to the nation state, but they have their own set of ops and the way that they do things. And sometimes they have other things, like, for example, with Iran, they might be trying to find targets for the Iranian government, but at the same time, performing ransomware ops at the same time. And so how noisy they are, how sophisticated they are, depends on if they care or not. And just to this point, I had a case where it was an implant from a Chinese threat actor that remained in the environment for 13 years. And you might think, damn, I want to see the code for that implant, or wow, that must be a really cool implant. But it's actually sometimes also a reflection on the blue team side, because it was not a very difficult to detect implant, and it was actually the issue resided in the blue team side, in the detection capabilities and the awareness of what was going on. So I think it's like a big thing in terms of like sophistication, questions around how stealthy you need to be, and really how sophisticated can an APT group get. And so, okay, we've backdoored pass-through authentication agent. But let's make it a little bit better. I don't want to install anything on the victim. I don't want to install a PowerShell module. I don't want to inject my DLL. I don't want anything to touch disk. I don't want any EDR being flagged. What can I do? And this is where cloud attacks become really sexy, because you start chaining different techniques together. you can actually perform this entire attack on your attack machine without ever touching a victim machine. How you do this? Of course, there are some attack primitives and objectives you need to meet in order to do this. But if you have hijacked an account with hybrid identity administrator account, oh, sorry, I'm rushing forward. But essentially, this little slide here shows you Nestori's tool. It installs it basically man in the middles all the creds, and it writes it to a hidden folder. And this is what the hidden folder looks like. It's adeptly named PTA spy. And it writes everything to a text file called PTA spy, and it records all the passwords in base64. And Henry is a global admin. So if you don't want any forensic evidence on disk, you can do everything on your own system. And the way that you do this is, if you have managed to hijack an account with hybrid identity administrator rights, you have the ability to install pass-through authentication agents on your environment and perform the attack on your environment. And so that gives you access to install the agent and set it up and connect it. And you might be like, okay, well, we have like conditional access policies. We don't allow random devices to be joined. Well, there's different ways to bypass that as well. But we won't go into talking about, otherwise I'm just going to be here for like 2 hours. So if you manage to do this, then you install the agent on your machine. And I'm not even using a server. I'm doing this on a Windows 10 machine. And just to show you, this is like my evil machine. I've just got Bloodhound running just for like the visuals for the slide. So the agent is running. I'm backdooring this agent. And what does the blue team see? Okay, well, the blue team doesn't have access to the box that you've backdoored. The blue team can't obviously touch what it is that you've installed. They don't see that you've done the skeleton key attack. They only see that a pass-through agent has been installed on a host. And obviously, my computer does not have a very nice name. It's called desktop 123 or whatever. So, but you guys, red teamers, you would name it something stealthier. Name it something related to the corp. I don't know, like Evil Corp 123 or something, whatever the company is called. But from the blue team's perspective, this is a really important distinction, because in an IR report, what will then follow from here is we see that a computer has had pass-through authentication agent installed. Subsequently, we might see logons. We cannot conclusively prove in court or whatever that a skeleton key attack occurred. It may have occurred, but we don't know. And the reason is the evidence doesn't exist. But if an evidence doesn't exist, it doesn't mean something didn't happen. It just means we can't prove it. And that leaves gaps in the analysis process where the blue teamer has to fill in gaps around this might have occurred or that might have occurred. And that, once again, relies on the blue team knowing what these attacks are and how they work and what it allows a threat actor to do. And this is where skill issues and the things come into question around education and knowing what to do. And so what about federation? And federation is like, I would say in a lot of the cases I've worked, federation is like a typical model that a lot of companies use. And in a federated model, I would say this is probably in the wild, the primarily attacked setup. And we're going to cover one example called Golden SAML. But when the Golden SAML attack came out, there were a lot of write-ups that were published. And in a lot of these write-ups, they used words like, oh, ADFS could have been exploited. ADFS may have been exploited. Something may have been exploited. It was really like wishy-washy. And I'm going to explain to you why this is the case. It is extremely difficult to detect. And we're going to go through a little example. But this isn't the only instance in the wild where ADFS was breached with Golden SAML. There are different types of attacks on ADFS, even one that occurred, I think, like last year in August. I think Magic Web happened, I think August. I don't remember the date. But this is like something that threat actors are very interested in, especially when it comes to on-prem to cloud. And to be honest with you, in terms of casework I've done, with APT groups, they're not normally coming in directly through the cloud. I tend to see like on-prem to cloud. It's always like on-prem aspect and then movement to the cloud. So before we talk about Golden SAML And this, I could talk about this topic for probably an hour straight, but I'm going to give you guys a very like TLDR output of what it is. But first, we kind of have to understand the auth flow. And I love this chart from Signia. So Lena, go and type in my username and password. I want to access my resource. What then happens is my access request gets passed through to Active Directory Federation services. It then checks if my credentials are correct. And if so, it uses a certificate that sits on the ADFS server, and the cert generates a SAML token. And that SAML token is what gets passed to the resource and grants me access. The premise of the golden SAML attack is that the threat actors manage to, and I guess the prerequisite is that they've already breached you on-prem. They breached you on-prem, and what they're trying to do now is they are trying to hijack the certificate so that they can generate their own SAML tokens in order to seamlessly log into the cloud. And that is the attack, essentially. And what I like about the attack, you don't need to download any tools, no tools necessary. You can do did I just touch that? You can do the entire thing. Sorry, a bit of a disruption upstairs. For those on video who don't know why I'm staring in the corner. So there's no tools necessary. You can do the entire thing in PowerShell. And how this works is, in order to do this attack, you just need domain admin rights or access to the AADC service account. And you need to be on the ADFS host itself. To do this attack, you need two components: a decrypted key manager and also access to the certificate itself. The certificate lives inside a configuration file on ADFS, which is an XML. And if you have those permissions, you're able to export it. Once you ascertain these aspects of the attack, you're then seamlessly allowed to forge tokens, SAML tokens, for any account with any rights. And so once you've landed onto the host, you can directly pivot as a global admin into the cloud, bypassing MFA. And that's exactly what it looks like from the attacker's perspective. I'm using Burp Suite now because I used curl on the previous slide. I just want to show you like some diversity. So I pasted the SAML token here, and that has automatically logged me in as Henry. And Henry is a global admin. It's directly logged me in. Okay, what does the blue team see? The blue team on the ADFS host, if you're looking at event logs, just sees 3 interesting logs. And what do these logs mean? They don't mean anything. They just mean that an Active Directory object was touched. They don't tell you how it was touched or what it was touched. I could insert a really inappropriate joke here, but I won't. But it just tells you that something was touched, and we don't know what was touched, okay? There's just not enough information. And you might go, okay, whatever. What about the cloud? That might show you something. But this is where IR in the cloud environment goes crazy. It's hard because from the cloud's perspective, the cloud just sees Henry has logged in with a valid token. And that's what the cloud logs reflect. And is the cloud logs wrong about that? No, because that is literally what happened. You've logged in with legitimate credentials, you know? And so there's just there's like a weird gap now between everything looking normal in the cloud and then the blue team not really getting logs that really show you anything. And so how would you even detect this? And this is where it takes you into hell zone. The detection for golden SAML exists entirely on detecting logs that never exist. You're looking for event logs that never are produced. What do I mean? When you perform a normal SAML, when you're like a legitimate human and you're not trying to do no crazy stuff, and you're logging in and the ADFS is generating the SAML token, it will first go, oh, Lena's creds are correct, and then it will go, okay, sick, here's your SAML token. These will generate logs on the ADFS host. But because you have stolen the certificate and you are now forging SAML tokens on the fly for whatever user, those logs won't exist. And so what does this mean for the blue team? It means that they then have to go into the cloud logs every single instance where anyone has ever historically logged in for the entire duration of the attack timeframe, which usually when you do an incident, you don't know the full attack timeframe at the time. You have to go and back check and correlate every single one of these logs to logs that don't exist. And couple this with things that like Russian threat groups do all the time, which is disabling Splunk forwarders. Maybe they're suspending the event log service. It creates like an entire world of hell. And also, I've worked with a lot of companies where they've spent millions of dollars on their Splunk instance and their Elk instance, and you might think, oh, that's just a sick, whatever, enter really sexy Splunk term. That's really easy to do in Splunk. But these instances are so slow, you have no idea. Even in a lot of government clients I've worked with, their Splunk instances are slow. So it's really difficult to detect. And so what is facilitating these techniques and what's really driving, threat actors moving into the cloud? The first one is cloud adoption. We're all aware of this. There's like over 200 different resources and services that you can do inside Entra. It's a mammoth. There's so many different things to do and so many different attack surfaces. The second thing is important data resides in the cloud. It resides in conversations you have in Teams. It resides in documents that you share, co-collaborate on, things that you do, you work with friends, you send them emails, you conversate. These snippets of information, ironically, is what makes threat actors are interested in that. That's how they learn about the ops and what occurs. The third thing is there are constant changes to the cloud all the time. And I'm not talking about Microsoft's obsession with renaming things. It's like the changes to how specific services run or new things that they then push out, new things that are changing all the time. It's new attack surfaces all the time. And we see that reflected in the real world where constantly there are new attacks occurring all the time. And then lastly, log ambiguity. The cloud doesn't care that you've stolen a token. The cloud just sees valid token signing in. And a lot of the times in blue team cases, I've seen instances where, we just see that the threat actors logged in, but we're not really sure how the initial access occurred or how the tokens were stolen. And a lot of that comes down to knowledge, log ambiguity, and also not really understanding that in hybrid environments, the cloud logs only tell half of the story. And so Microsoft is doing the right thing. They are moving in the right direction. I'm really excited about this push as a blue teamer. You guys are probably not so much excited as red teamers, but Microsoft Graph activity logs are now going to be logged inside the Microsoft portal, and this was announced in October. But with that said, we can evade it. So for some reason, this log only logs calls to Microsoft Graph API. It does not log anything related to Azure Graph, the deprecated API, which you can actually do literally one-for-one the exact same things in. And so if you don't want to use a framework like AAD internals, which a lot of the PowerShell scripts in there leverage Azure Graph, you can leverage Azure Graph yourself. There's still documentation on Google. Basically just port everything to Azure Graph instead. And if all comes to worst and you've done a whole bunch of stuff and you still want to hide yourself, you can always forge your logs completely. And this is an attack on ADFS, on Federation environment, where I have gone ahead and I have forged these logs, and they make no sense. But, as a red teamer, you would go about it in a much more sexy way. But this is where it gets really interesting. Because if you think about an attack like this from blue team's perspective, Sombra's logged in from an application called Not Applicable, okay, and she's logged in from a really cute IP address, awesome. But in terms of from the blue team's perspective, no blue team in their right mind is going to go into an incident and throw out the question, but hey, everything could not be real. Everything is fake. No one's going to start an incident with that assumption that the actual thing that you perform your entire investigation on, the integrity, is compromised. And that's what makes cloud attacks so interesting and so exciting, because in the world of cloud, you can chain all these different techniques, do all these different things. And yeah, that's what I think, for me, makes the cloud really exciting place. And if you're curious about different attacks in the cloud, I've built an attack matrix. This is the third iteration of this, I think. I'm going to be releasing another one, probably end of the year-ish, depending on my mood, I think. But this covers all the different attacks you can do on the cloud. Now, it's interesting. I've had conversations maybe last 2 days with people where a few people have brought up to me the question of, oh, the cloud is just someone else's computer. Why do I care about the cloud? Yes, the cloud is someone else's computer, but a lot of the attacks focus on the platform itself and not the actual endpoint itself. And so all the attacks I've just talked about, some of them cover the endpoint, some of them mess with the platform itself. And most of the attacks that you see here are focused on the platform and not on the endpoint. And if we think about who really is targeting endpoints in the cloud, it's just like your normal threat actors. But a lot of the cases that I've worked with endpoints being touched in the cloud tend to be like commodity-driven threat groups like coin miners, crypto, like, Monero coin miner installations. And those threat groups, those jobs are not super fun, but they are pretty funny. Like sometimes what they do, like I had a case where one of the coin miners was writing poems and like Adele lyrics and Taylor Swift lyrics, and yeah, it made the job go by pretty quickly. But yeah, with that, I hope you guys got a lot out of it. And thank you guys so much for the opportunity to talk with you guys. There's an entire day filled with talks. And yeah, if you want to talk to me, you can hit me up on Twitter. And thank you.
Thank you so much for your talk. There are a few questions. The first one is, do you feel like cloud vendors such as Microsoft are not thinking enough about security when they are implementing these type of technologies?
I think that this is a difficult question to answer. I think that when they implement certain things in the cloud, their first thought is about the thing that they want to implement and how they implement. They don't necessarily approach something thinking, oh, I'm going to implement it this way, and oh, it could be misused this way or that. That kind of happens after the question. Yeah, I think that's kind of normal though to do it like that, and then hackers like you guys come along and mess everything up.
Then there was another question, a little bit more technical, about the skeleton key attack.
Mm-hmm.
So they asked, when you do it in LSAS, you kind of have to downgrade to RC4. Do you see that as well with doing that in the clouds? Like, how does that work?
No, it's sent in plain text to the agent. That's the difference. Yeah, so when you type in your creds and put in your stuff, those creds are passed in plain text over to the agent itself.
Yeah, I think that's it for people online. Anyone here in public that has a question? Okay, thank you so much.
Thank you.